Yeah, sure. 10 minutes. I've got the time. So we're going to start. Yeah. Good morning. Welcome to DNSSD, and this is the first session of the week. So good to get started your IETF week, having exploring some DNS service discovery. If you take us forward. So, as I mentioned, this is DNSSD. I am Chris Box, and here is my co-chair, Florian. And here is the notewell. So this is a reminder about the policies that you agree to follow when you participate in the IETF. It covers conduct, privacy, and intellectual property rights, so please read it carefully. You're encouraged to read the source documents to which the notewell refers. The QR code will take you to those. If you have any questions, please talk to us afterwards. And if you're in the room, please make sure you sign into the session in Data Tracker. Everyone, regardless of whether you're at home or in the room, you can use the Meet Echo client to join the queue. And when you are speaking, or before you start speaking, please state your name. So we have a GitHub organization where we host our working group documents, but individual draft authors can also contact the chairs to get set up. So we have a number of documents, and this is the status of the adopted documents. Multiple queue types is currently being edited by the RFC editor. TSR and advertising proxy were recently updated, and we'll cover those. SRP replication is on hold, but will be returned to. We have a number of relevant individual documents. Infrastructure and SIG0 will be discussed today. Removal services is not on the agenda, but we may come back to it. So this is our agenda that we're planning to go through today. Is there any request to change this order? In that case, we can move on. So we have, the existing charter for the group is relatively old, and we need to revise it. That link there hosts the proposed text, but I've got it on the next slides to so that you can have a sense of it if you haven't had a chance to have a look at that. So the charter starts with the background, just like the old one did. It talks about SRP, it talks about discovery proxy, and the ability to discover services using unicast DNS. So if you go back to the, so we also now have, we lead on to at the bottom there, the example deployment of this technology, which is in the thread border router, which implements a snack router, enabling bidirectional discovery between the thread mesh network, which uses SRP, and Ethernet, which is using MDNS, and which is, of course, used by Matter. So that's one example of the deployment of this technology. So that's the background. If you go on to the next slide. So what we're proposing now for the charter for the working group, the part at the top is the same as before. The main items to work on, so we've got 4 of them shown there. So defining how to publish SRP registered names in multicast DNS, defining mechanisms that improve the efficiency, availability, and effectiveness of DNSSD, and defining how to resolve conflicts between competing updates of the same name. And the last one there, describing how the different protocol components can be combined to make a complete DNSSD service that is equally accessible by MDNS and SRP clients. So if you have any thoughts on whether those are the right goals for the working group, please join the queue. There's a final section on the next slide. So we'll consider the privacy and security requirements, collaborate with SNAC and other DNS working groups as appropriate. We will not integrate with other zero configuration service and naming protocols, and we will not update general DNS protocols unless there's an exception. So if you go back to the previous one, does anyone have any thoughts on that charter?
So, Ted Lemon, I apologize for not having read this as closely as I should have, but I don't see there the thing that I think we need to do for advertising proxy to make it less punchy on the network, which is some updates to MDNS to talk about how proxies cooperate, which I don't know if I don't think it necessarily requires a protocol update, but it's kind of a multicast DNS topic. So I don't know if this charter, maybe the first bullet item covers that. I guess it does.
Does the second bullet cover it?
Yeah. Okay. As long as basically the thing I'm trying to avoid is having MDNS protocol changes, if necessary, be out of scope. I don't want that.
Understood. Let's try and make that as clear as possible. Let's go.
That's correct. So I saw there was a part about not kind of interoperating with all our protocols. That was the explicitly excluded part. So, but other working groups can basically do something that integrates with DNSSD, I think, right? That's if it goes the other way around. So I was still thinking like in the future there might be some mapping defined between basically the core working group, link format discovery or resource directory, and what DNSSD defines. So I think that could be in scope, but not in this working group, I guess. Then but others can still do it, right? So that's
we are only defining what this working group.
Yeah, indeed. Yeah. No, so that's okay then. Okay, thanks.
Thank you.
Frank Brockner, so I have a bit of a stupid question. Is it like if we define new service types, say for agent discovery, for instance, on a local network, would they happen here or would they happen in Dawn? Maybe that's a question for Eric.
Stuart Cheshire speaking for myself. To answer that question, I think it makes sense for this working group to be an area of expertise. So if other working groups have questions, ESCO talks about the core working group. If they're writing up some draft that relates to this, then they can certainly circulate it on this mailing list to get expert review. And likewise, you were talking about, I've been hearing discussions this week at the IETF about, well, everything's about AI and how do you discover AI agents? Maybe that's no harder than discovering a printer, or maybe there is something different about an AI agent that's different to other bits of software. That is something certainly where we have the expertise in this room to have that conversation. That doesn't make it a chartered work item for this working group, but we can act as consultants to other IETF working groups to advise them and guide them and brainstorm ideas.
So Eric has a responsibility for DNSSD. And basically rephrasing what Stuart has said, it's quite common that we ask for expertise in other working groups, right? Happens maybe here or maybe other part. So that's normal. And sometimes the chair of other working group will extend the working group last call to the DNSSD, for instance. So if there was something to be done in an AI-related working group, this AI-related working group will most probably, the chair will ask forward the working group last call in their working group to the DNSSD to provide inputs. And typically the responsibility double check as well. And other points not related to this part, the charter is really a contract between the IETF community and this working group. So it's really important. So I really ask everyone in the room to read it, because that's very important. And thanks for doing the job.
Yeah, if you go, so this charter is hosted in the GitHub, and there is one issue opened in there, which is I think Esko, you touched on this previously. So there is an open question whether we need to add something about this point. So this is about the timing of messages and trying to make that more Wi-Fi compliant. And it's just a point for you to consider. Does this this item of work, do you see that as fitting within the work items? So if you go back onto the, not that one, that one. So again, this second bullet point here is define mechanisms that improve the efficiency, availability, and effectiveness of DNSSD. So if we go forward to the open item again, please. So this is clearly an efficiency point. However, if we wanted to, we could make it more explicit. So if you have any opinions, please come to the mic or join the queue.
Ted Lemon again. I think it would be, like you say, DNSSD. And if we understand DNSSD to encompass MDNS, then that works. But if we don't understand it to encompass MDNS, then it kind of doesn't. And I think that's my concern. So that's why I'm saying, like, you could say DNSSD including MDNS, and that would address my concern.
Makes sense.
That's correct. So I think I wanted to say exactly the same. So it fits well within that bullet if we include MDNS somewhere there for the efficiency part. Yep, thanks.
Thank you.
Shall we still do a show of hands with, saying we will clarify MDNS?
Yes.
Okay.
Yeah.
This is probably getting too long.
So we're slightly ahead of time. So I'm just going to, so just do a show of hands. So the question is, are you happy for this charter text proceed, assuming that, if we make the changes that have just been made, so we clarified that multicast DNS is in scope for the charter. This is not committing you to anything, but is it your current feeling that this charter text is a reasonable one to proceed with? And it's perfectly valid to say no. And if you think it's not quite ready and you haven't expressed why, then we love to hear why, because we want to get this right. And this is also a cunning way to make sure that everyone's signed in to meet. Okay.
See, Andre still looking for students. Seems to be stabilizing.
Okay. Oh, just adding a few more. Okay, I think we can finish there. Thank you very much. So that concludes the next part. So we can move on to the next item. So if you want to share those slides.
Share slides.
So Carsten, if you'd like to come on, thank you.
Yes, hello.
Hello.
My name's Carsten Sperling. I've recently come on board with Ted as a co-author on the full service DNSSD or DNSSD on infrastructure draft. The name is a bit in flux, I guess, still. And I apologies for not getting the draft out before the blackout. It was held up a little bit on our internal legal wait states. So we unfortunately could only share the draft GitHub document to the mailing list. So I don't know if people have had a chance to read it or not. So I'm going to just sort of summarize briefly what the changes are that we've made, and then probably open it for any questions or discussions. So the first thing is that we've decided to give the thing a slightly more distinctive name. DNSSD server sort of sounds a little bit ambiguous what exactly that means. So we thought we could call this thing Unicast Local Discovery as a sort of makes a good acronym as well, ULD. So that's just a little side bit. Can I change the slides myself, or do you have to move to the next slide from your end? Thanks. Yeah. For those not familiar with the draft so far, the goal is essentially to do link local discovery in a way that involves no multicast or minimal multicast, because especially on Wi-Fi networks, multicast discovery has obviously multicast has various issues around the lossiness of multicast packets, and especially for power constrained clients that would really like to sleep, for them being able to receive multicast and respond to their DNS multicast DNS requests means they have to essentially be awake for all the DTIM beacons to do this. So we're looking for a way to have a central server act as an SRP, registrar, discovery proxy, and advertising proxy, and a unicast server, and for this server to essentially handle DNSSD discovery via unicast on the link. And when such a server is available, the idea is that those clients that understand this protocol can then just ignore MDNS traffic and don't have to themselves participate in MDNS, but they will still be discoverable in MDNS via the advertising proxy, and they can still discover MDNS services via the discovery proxy and advertising proxy. So the changes from the draft version 2, the biggest changes that we say we want to directly use the .local domain for both for the registration via SRP and for the queries from clients. This is because essentially we want to encourage that ULD can be adopted at a sort of system or DNSSD library level rather than having to be adopted by individual applications. So ideally, we want to define this in a way that these libraries can implement this unicast alternative to MDNS, and then more or less transparently adopt this. So for that to work, we want this zone that ULD uses to have the same semantics as .local, or put another way, we're interpreting .local to be a semantic thing, meaning services on that link rather than a thing that specifically selects MDNS as a transport. So as a consequence, essentially we sort of have to say we're updating RFC 6762 to say .local queries must be sent to either the ULD server or they must be sent to multicast, whereas currently MDNS mandates that they be sent to the multicast addresses. Everything will remain kind of link local. Clients can connect to the ULD server using a link local address, and that preserves the link local scoping. And off-link queries for a .local name are refused by the server. And then a sort of positive benefit of using that .local directly is also that the rewriting that advertising and discovery proxy would normally have to do are then no ops. Sorry. Some other changes are that we've refined a little bit how the ULD server itself gets discovered to explicitly use like a normal DNSSD service, whereas previously it was sort of defined to just directly use specific SRV records. So we're suggesting a service type of maybe ULD.TCP that needs to be registered still, of course, and the text record carries a server priority in a text key, and we want both infrastructure and ad hoc servers to be advertised in this way. And one of the benefits of this is that then ULD clients themselves can use ULD to do this DNSSD query to find a potentially better service. And we've added a tiebreaker that allows that makes it kind of unambiguous which server is the most preferred. So they get sorted by priority order, and when there's multiple with the same priority, then we choose the one with the lowest link local IPv6 address. And that means clients in general will converge on the on all using the same server on a particular link, with the infrastructure server being the most preferred server that has priority 0. The infrastructure server also advertises itself via an RA option that's to be defined in detail. But the way this is currently envisaged is it just needs to be a flag that essentially says the router that's sending this router advertisement is the infrastructure ULD server. And one sort of side benefit of that scheme is that, well, first of all, it provides a sort of quicker way for an IPv6 client to discover the infrastructure server if one exists, because it already receives RAs anyway. And the designation of the infrastructure server can also be protected by RA guard on networks that deploy it. Then there's some other smaller changes. We're discussing in more detail how query results that are received over unicast, how they get combined from the responses that come from the zone that have been registered via SRP and from the discovery proxy, i.e. how those results have to be combined. We've also got a small thing there that allows a constrained client that doesn't support TLS to do standard unicast DNS queries to obtain shared records. So this discovery proxy, the way it's currently written, sort of only envisages the use of standard queries for unique records, because the response is always it just responds with the first records that come back, which may not be the complete answer. And then even if you query repeatedly, there's nothing that currently guarantees that that when you query again, you won't just get the first response again, but that you'll actually eventually get to the full set of services. So we sort of have a little scheme defined for how the server just effectively has to treat it as if there's a short-lived DNS push subscription, and then that way a constrained client can perform a short sequence of queries and get the full result set for a set of shared records. We've added some discussion of IPv4 and dual stack support. Essentially, the preferred and required support is for IPv6, but the server must also participate in MDNS on v4, so that discoverability of v4 only services is possible over ULD and the other way around, that dual stack services continue to then also be discoverable by IPv4 only MDNS clients. And then the remaining changes we've discussed when a CE router should claim this infrastructure status. So infrastructure being the most preferred service that's expected to normally be deployed intentionally on a managed network. It has to be deployed intentionally by whoever manages the network. But in an unmanaged network like a home network, we sort of have some suggestion for when the CE router should claim this infrastructure status by default. The remainder are mainly sort of editorial changes and just focusing the text a bit on this link local use case. We've got a few things that are sort of still open that maybe be good things to discuss here, or obviously we'll happy to take other questions. One question is that to encourage this sort of library level adoption, I think we need to provide a way for a DNSSD library to sort of preserve its existing API contract in terms of how conflicts on MDNS are handled. So obviously we can handle conflicts that happen within SRP are handled via the YX domain response, and then the client can decide to rename how it chooses. But if the conflict exists only on exists only on MDNS, then there's currently no feedback. So I think it would be useful if there was a minimal amount of feedback from the ULD server to the client about the fact that an MDNS conflict exists for any of the records within the SRP request. But that's not in the current draft yet. That's sort of an open discussion item. Another open item is whether we should support ad hoc, all servers, including ad hoc servers, advertising themselves via the router advertisement option. In that case, the option would need to carry more information than just being a flag. Currently, it's for the infrastructure server. All the information is already essentially present just by knowing that server is the infrastructure server. One other item is this: what I mentioned about these using supporting standard queries for shared record queries. A different option would be to maybe allow link local DNS push to use TCP without TLS, which is currently explicitly prohibited. So that could be an alternative or additional option to supporting these repeated standard queries. And a final question that's not at all touched on in the draft currently is whether we should do anything about reverse address mapping requests, which in MDNS, of course, also get handled. So should we also support them, or do we not care? But that's an open question. So these were my slides. I think happy to take questions. I don't know if Ted has anything he would like to add specifically.
Sorry, I had to push the raise hand button. Oh, Eric's first, though.
No. Oh. So Eric Link has not a responsibility this time. So Carsten, first, congratulations, right? First draft, as far as I know, first presentation, remote, which is not easy. Having said this, I read the part about the router advertisement part. I think the text should be made as crisper and stricter. It's kind of ambiguous right now, which is normal basically for this at this stage. You also most probably need to say, hey, I have no array with this flag. I got something I learned from MDNS, then I received the array, which is the winner. In this kind of the race condition, I don't think they are yet in the text. Again, congratulations.
Thank you. So on the, I think we've got some text currently that says sort of the infrastructure server also advertises on MDNS, so that the MDNS list should always be complete, but your clients are required to check before they trust that something really is priority 0 infrastructure server. They must also check the route advertisements. That's what the text currently says. I guess it doesn't really specifically say what happens. Yeah, like you said, what if for some reason it's not in the MDNS list? I guess that's a case that normally shouldn't happen if the server does what it's meant to be doing. But maybe we need to think about if we need to handle that somehow.
So I swear I pressed the hand raise button, but it didn't seem to happen. So apologies. Regarding the router advertisement, I think we're maybe like the sort of question of whether it should be advertised in ad hoc servers or not, and whether it should be is it harder to do a flag? I think the answer is it's just as easy to do an RA option as it is to do a flag. So if we think it's at all useful, and I actually personally do, to use router advertisement for ad hoc servers, then why don't we just make it an option that says that this is available in all cases? So in other words, the infrastructure server says, hi, I'm the infrastructure server, my priority is 0. And the ad hoc servers do the same thing, except they put the same priority that they put in their text record in the RA. Now you don't have to do the MDNS query to find out what the priority is, and that saves you. I think sort of requiring the MDNS query is kind of not accomplishing the goal here. Like, we want to minimize traffic, and so if we can avoid that query, that's a good thing. That was my motivation for doing it in the ad hoc servers as well when it's possible. So that's that. Totally agree with the DNS push over TCP. I think when we did that requirement originally, we didn't really have the constrained device use case in mind. And so we were thinking about user privacy, but a typical constrained device doesn't have a user privacy issue because it's a light bulb. So probably we don't care what domains it's looking up. And then on the topic of MDNS conflict stuff, I actually, I was thinking about this because we had a big debate about this privately a couple of weeks ago. We don't see eye to eye on this, if anybody was curious. And I realized actually it kind of doesn't make sense to say, and that doesn't mean that you should shut up about it, but I'm just saying it doesn't make sense to say this in the ULD draft. This is actually an advertising proxy issue. And we have an advertising proxy draft, so we should really specify this in the advertising proxy draft, because I don't think that it ought to be different for ULD than for other advertising proxy use cases. I think other advertising proxy use cases are essentially the ULD use case without all of the nice handy extra ULD wrapping on them. So they're they're the ULD use case, but we just didn't have ULD yet. So then we should just do this in advertising proxy. As for whether we should do the conflict stuff, I will point out that the main motivation for doing the conflict stuff is to deal with non-conforming, basically clients that behave badly, right? So we decided we wanted to use the .local domain instead of some other domain because that's what everybody does now. And there are people that are abusing the MDNS APIs on Apple devices, probably on other devices too, but I happen to know the Apple case. They're abusing the API by providing a .local domain when what they really mean is the default domain. So in other words, they're explicitly saying use .local when what they really mean is use the default discovery domain. And because they're doing that, we have this problem that we sort of feel like we have to use .local and we have to suffer through all of the broken, necessary for MDNS, but broken for DNSSD collision detection stuff, right? So I'll talk about this a little bit more in the advertising proxy presentation, but I think we should maybe think very carefully about how we want to solve this. And your approach may be correct, but let's have a good, solid working group debate about it.
I don't know. Am I meant to raise my hand to respond to any of these questions, or I don't know what the process is? I'm sorry. I think, yeah, thanks for those comments. I think maybe one point I wanted to make about, I think, yes, it would be great to handle as an advertising proxy. I do think ULD is sort of slightly different from the generic advertising proxy use case, and that advertising proxy just sort of says well, you've got some zone that's sort of different and you're just mirroring it into MDNS, whereas here we're more explicitly saying actually ultimately we're trying to have the same zone visible on both protocols, so you've got interoperability both ways with MDNS devices and devices that support ULD. So I think the promise of interoperability is slightly stronger, and I feel like there's less of a case of just saying who cares what happens on the MDNS side. I feel like we have a slightly higher bar of what we should aim for there.
Okay, Scott Eijk. Yeah, there are can be a lot of discussion on this slide alone. I think just 2 quick questions. I think for the priority item, it says in the text record. I was just wondering, why not use the numbers that are already in the SRV record there for priority and waiting?
I don't know, maybe somebody else can answer that better than I can, but my understanding was that they're defined to be priorities for different servers within the same service, and therefore not applicable essentially in this kind of use case where you're distinguishing different service instances, but maybe I may be wrong.
Ted Lemon here. I think that the reason that we do that is actually just because the API currently doesn't expose the priority. And so we would have to change the API in order to support it, which is kind of a bogus reason. But nevertheless, that's the reason.
Okay, I think I saw that kind of problem before in some cases in the past. So not sure what we should think about that. But okay, that's.
There's a case you need, we should fix it.
Yeah, indeed. And the other question was about the reverse address mapping. So was that a? Yeah, I'm not sure what the background was. That a question like, should the ULD server actually do this or implement that, or I'm not sure what was the question there.
Yeah, I think essentially the question, like MDNS says that when you have a reverse mapping query for a link local address, then it gets sent to MDNS. So if we're sort of saying, hey, ULD can kind of step in for MDNS, does that mean we should they be directed to the ULD server, and the ULD server should do something meaningful with it? And if so, how does it get all the? Does it have all the mappings? I don't know. I haven't quite thought through that, whether it could meaningfully respond to these in all cases, I guess.
Yeah. Okay. Yeah. The question maybe at high level is handle it or ignore it, kind of. Okay.
Right.
And yeah. Thanks.
Ted Lemon again. So the way that works in MDNS currently, at least on Apple devices, is that if you do a reverse query for a subdomain of IP6.ARPA that is locally resolved, or if you do a query for, what is it, the 169.254 addresses, it will actually do the reverse lookup of that specific name using MDNS. So in other words, not doing .local, it's doing inaddr.arpa, but just for that specific subdomain of inaddr.arpa that's always guaranteed to be locally resolved. So I think it does make sense to include that behavior here as at least a should. It might not be a must because maybe you have a device that just doesn't have the resources to do the extra stuff, and maybe we don't want to consume that bandwidth. But it is beneficial. I use it. I personally have used it for debugging in the past. It is helpful for me. So speaking very self-interestedly, I'd like to have that functionality just for that reason. But it's certainly worth debating whether we really want that. So that's where I'm at.
François Michel. So small clarification question. Are there, for the first bullet, actually the second one, the first sub-bullet, are there signals that we cannot right now already carry through return codes? I think for conflicts, there are already some return codes we could use. Complicated? In what sense?
This is the protocol level. The issue is not at the API level, it's at the protocol level. Like, what do we do? Do we actually have SRP be able to signal back that we got an MDNS conflict or not?
Yeah, okay, I thought it was at the protocol level that we were discussing, but it's actually just at the API level?
No.
Okay.
No, it's at the protocol level.
Right. Right. I thought that was the actual question of the slide.
Maybe that's just my framing of the point. Essentially, the point was that DNSSD APIs tend to provide a way. I mean, most of them provide, when they do auto renaming, they tell you what the final name was that you actually got. and many APIs also support telling you and telling the application and letting the application handle the name. At least some support that, and I think for like Avahi, for example, that's the only way it handles it, as far as I know. So essentially, if these implementations want to keep supporting that behavior for MDNS conflicts, even though they're going via ULD, then we need that kind of feedback information in some sense, because the other alternative that was previously an advertising proxy was that the advertising proxy itself rejects the whole SRP registration until MDNS is kind of acquired, and that was sort of rejected as not the way things should go. That essentially the SRP itself should accept the registration if there's no conflict within its zone, and so that only reject for SRP conflicts and not reject for MDNS conflicts. So the proposal is sort of not to relitigate that, but that's just to add a little bit of extra information so that you can recover that extra bit of information on the client side to say, okay, the SRP registration was successful, but there is an MDNS conflict.
I see. Thank you.
Actually, I have So what would you like to do with the draft next? That's individual draft.
Can we adopt it?
We probably could, but then you're not in the queue. So. Okay, we will ask on the list.
So I'm just going to do a show of hands to get a sense of the room. So.
Actually, I just wanted to add a comment about this because maybe Carsten said it and I missed it. But I think it's worthwhile pointing out some of the background, why people are interested in this. Matter is getting very successful these days. And if you put 100 devices on your Wi-Fi network, that becomes a lot of multicast DNS traffic. Multicast DNS was great when you have a laptop and a phone and maybe half a dozen devices, but you put 100 or 200 IoT devices, the multicast traffic it becomes out of control. It doesn't scale well. So there is a lot of interest in Matter about how to do more scalable, more efficient discovery. So that is the motivation for why there's interest in doing this right now. Oh, and I should add, it might not be obvious to everybody, with Thread, we already did this because we knew we didn't want to flood the Thread network with lots of multicast traffic. And that's worked very well for Thread. And seeing how that works for Thread, there's now an appetite for, could we do the same thing on multicast as well, on Wi-Fi as well? It's a bit more of a challenge on Wi-Fi. I don't want to make it sound like it's really hard. With Thread, we had the luxury that we had a greenfield development. So just starting from scratch, we said, this is what we're going to do, and everything works the same way. Now that we've got 25 years of deployment history of multicast DNS on Wi-Fi, we need a forwards backwards compatibility migration story so that your 10-year-old device doing multicast DNS continues to work. So there's a little bit more factors to consider on Wi-Fi because we have that legacy, but conceptually it's the same reason for doing it on Thread.
Thank you. So we had 11 people say yes. There were no no's and 18 no opinion. So we can now move on to the next section. Yeah, TSR is up next.
So,
Oh,
testing. Timer check. Hello, everyone. I'm Esko Dijk. I'm presenting the TSR draft here, multicast DNS conflict resolution using the time since received
is that
DNS option.
This works.
Thank you.
I tested it.
So this is a kind of quick graphical recap of what TSR is doing in a specific deployment scenario. So I also showed this last time, so that would probably mean that I'm now going to go quicker over it, but it's good to show it. So that basically shows a network topology where you have two so-called snack routers. Those are devices defined in the snack working group, so a sort of an ad hoc IP router that can basically act as a router on behalf of a 6-LoWPAN network that's behind it, or another type of network technology. So 6-LoWPAN is, for example, an IoT mesh network, like defined by Thread. And there we do use basically SRP registrars and advertising proxies as defined by this working group. And now you can have basically device using a unicast update in this mesh network to register its records, and then those get advertised on the AIL, which is the Wi-Fi or Ethernet link in the home. So there's a TSR option added. So at the moment of initial registration, the TSR is 0, so that's the time since received. So that shows that the records are fresh when they're advertised. Now, there can be a change of situation, so that's shown in the next slide, that suddenly, for whatever reason, the device now has registered to another SRP registrar. So it can't reach the first one anymore, or maybe that went down, whatever. It goes register its service at second one, so that it's still findable in the home and can keep functioning. Now that one also advertises the same service, which would normally be a conflict, but now we have the TSR option included, says TSR 0, while the one on the left, which might still be advertising on the AIL, has a TSR, for example, 300. So it's like 5 minutes ago, I received the last update. And now that means with the TSR option that the newer registration basically wins. There's no conflict between the MDNS records, but rather the old one, the stale one, is removed automatically, and the new one wins. So it's also verified that this came from the same original requester, the green circle. So that's what it's about. And yeah, next I will be presenting just quickly the updates since the last IETF. We talked about this, and open issues that are currently there. So what are the updates? So there were quite some editorial updates, so more consistent use of terminology, applying SRP terms, clarifications. There's now also an informative references section. And there's at least double, yes, double, the number of defined terms. I'm not sure if that's good, but at least this shows that we're more formal about it. So there's really more formal definitions for the things we use. And that's good, because it makes it more specific, I think. And there's an option format that's shown on the slide here. So that's a graphic of the option instead of just describing it as text. And there's one more update slide. So there's some more details, mainly on the probing and the processing of TSR, and also use cases, so when to use TSR. There were some sections added about suppression. So that's basically to specify when the MDNS messages, what cases they are not sent, to make it more efficient on the wire. We have a section with details on how to handle multi-packet MDNS advertisements. And there's an appendix added, so that has an example showing a particular case in detail. So that's all about the updates, and that resolved some open issues as well. Looking at the open issues in GitHub at this moment and in the document itself, this one came up. It's a bit of a scope question. So that came from me actually. So while editing, I thought it was still unclear what is really the scope of section. Basically, that's 3.8 that talks about replication. Should we be mentioning that at all in the draft? So the idea is that TSR can be used by a proxy type of device, and that proxy type of device could be replicating DNS records with other devices. So we have a draft for that in the working group, the SRP replication draft. So it goes through a quite detailed scenario there and also has some normative requirements. So it's mixed together. And I was a bit puzzled about that. So I think the proposal I had from my point of view is that we should actually specify the processing of TSR kind of independent of what's the origin of the records. So that's the registrant basically supplies the records, and there's the registrar that advertises them. And yeah, maybe we should have kind of generic rules for that processing of TSR, regardless of where it came from. So that proposal here that I had is like we can still have a nice walkthrough about, well, what happens in the replication case, but should not be mixed, I think, with normative requirements specifically for that case. And I see that has something to comment on this, so go ahead.
Yeah, I think anything that you see in the replication draft, it's an old draft. We haven't updated in a while, and it's probably going to change a bit. So when we do finally update it, so you shouldn't worry too much about that. When it comes up, we can fix it.
Oh yeah, but it was in the current draft. Basically, TSR had a section about, well, in replication cases, do X and Y. Yeah. Basically,
there is actually so one of the things that kind of came up, and Francois will be talking about this later, is we have the ability to tell whether the data is the same in two updates in SRP now, and I mean we always had it in theory, but now we actually have it in an implementation. And it occurred to me that we could actually flag that in the TSR option as well. Like this is the checksum of the data basically. And then if we get, because the problem is right now with replication, we have the issue of timestamps being slightly off because we don't rely on there being accurate clocks on synchronizing devices. So that's really the issue. That's the reason why this gets talked about. And if we had that hash of the registered data as part of the TSR option, then we could use that as part of our process of disambiguating and determining whether data is stale. And so basically if the hash is the same but the timestamps are slightly different, we can just treat it as equal rather than trying to just determine a sort order. So that's why I wanted to talk about that.
Okay.
Because we like this is the TSR document, I would say, is practically ready to go. And so I'm a little reluctant to add something to it at this late date, but that would actually be kind of a nice thing to add to it. So,
yeah. Well, here I was thinking about splitting some things. So if you have a specific, replication scenario, you can go through it, but it should not cause specific processing because the registrar knows, like, hey, that client of mine is a replicating thing, so I must treat it differently. I think that's not a good okay, but that needs some text proposals, and then maybe to consider the idea you just had with the checksum. That's still open question then. All right, then let's move on. Just wanted to go over the open issues here. So the other one was came up also while editing. Why is there always a probe on updated records? And this figure here is a bit to explain the context. So the actual problem is on the next slide. But to explain the context, you have this IP node there with an MDNS registrar, and that has two sort of storage compartments that we define. So there's the cache and there's the local registration database. And any one of them could have a specific set of records, or both could be there, or they could be there with different properties. But I think the idea there was that in the current draft, this basically says that if the registrant, which is the process A here, basically just updates its records in the local registration database that were already in there, and now it just changes a small bit. So it's kind of a refresher basically of its own records that are already there. Then there is a probing done. So I'll move to the next slide to explain that. So that's basically text in the second bullet here. So the requested records are added to the local registration database and put in the probing state. And that also applies when the records were already in the local registration database. So this seems a bit weird to me. So we have a process that adds records that are new, that's probed, and then it updates the same records, and then probing is done again, while the registrar was already authoritative for those records. So I thought that was probably not the intent. So might need to look at how to reword that if that was not the intent. I see Ted at the mic, so go ahead if you want to comment.
Yeah. So as I liked your diagram. Thanks for putting that up. I realized that so MDNS Responder does that, right? That's probably maybe where that idea came from. Maybe not. I don't know. But it's interesting, so we're basically doing the probe in order to update our local cache, but you could actually think about this as two different servers. One of them is the caching MDNS resolver. Sure.
Okay.
I just want to jump in here
Yeah.
to make sure we're not confusing the terminology, because there is probing and there is announcing. And probing is, as the name suggests, I propose to use this name. I want to check if someone else is using it. If you find that the name is available, then you announce that now you're using it and you give the data. And I believe, unless my memory is failing me, Ted was talking about the current behavior of the MDNS responder code. When you update a record, and there is an API to update a text record, it does not reprobe to see if the name is still available because you've already done that. It just announces the new data. So are we talking about probing or announcing here? I worry we may be confusing the terminology.
So the problem with what you just said is that the API doesn't actually provide a way to update the record that works for us. You would think it would, but it doesn't. So what winds up happening is what we were doing originally in the implementation, this is the SRP implementation, not MDNS Responder, was we were registering the record, and then when it was updated, we would remove it and re-register it, which would cause a probe. We modified that behavior in a really hacky way, which is that now when we get an update, we update the record. Sorry, we re-register the record. We don't do an update. We re-register the record, and then that causes the old record to be removed as stale, right? So in other words, we have two registrations active at the same time, and the older registration is removed as a consequence of adding the new registration. And that prevents the probe from going out. So the reason why we want to say this in the document is to make sure that it gets implemented in a way that preserves this behavior. And that clarification. So I was going to point out also that maybe we don't even need to send the announcement, because the announcement is only useful if somebody is interested in that data. The reason we're sending the announcement is because if somebody were to do a query on the local MDNS cache, our locally registered record would not be in the cache because it hasn't been announced. Like the stale old version would still be in the cache. So we need to do the announcement to kick it out of the cache and put the correct stuff in the cache, which actually applies for other caches as well. So I think we really do need to announce it. So I think that answers that question.
Okay, but there's still the question why we say probing. Then maybe you've already answered it, but
so I thought that we updated it to not to say that probing was not required for TSR updates. If I'm incorrect about that, we should definitely update it to say that, because we shouldn't be doing probing if the only thing that changed was the TSR record. The only time we would want to do probing, or actually we shouldn't do probing on a name for which we've already probed and have a TSR record, because the fact that we probed for that name means that we own that name, I think. Stuart, is that right? Like if there's a new record, that we don't have to probe for the new record because we already own the name.
Yeah, that's the same I read in MDNS, basically, yes.
Okay, I'm going to try to be precise with the terminology, because records have a name and they have our data. So if you want to use a new name with multicast DNS, you have to check that the name is not in use. If you want to update the R data for an existing name, then if you've already verified that the name is unique, you're free to update the data as much as you like without reprobing, because you've already claimed that name and you're defending it. So hopefully, was that clear?
Yeah, that was clear.
Great.
Thanks.
Thanks.
Hi, Jenny, yeah, with AT&T. So, sorry, I just recently get into this, reading this stuff, and then my question is not related to this proposal, but rather the original and the initial diagram you showed there. So I saw that you got no SNAP router with the advertising proxy showing there, but based on my reading on the recent SNAP router proposal, you said the SNAP router is not going to have advertising proxy requirement. So there is no advertising proxy there.
Well, it still has it, so it's
Okay.
basically included in the current version of the snack router document. Snack simple, yeah.
Is there? Because the
Yeah,
text on my reading, it says, oh, this is because it's out of scope. There's no advertising proxy there, because that's what actually saying like feedback to the group mailing list.
I think, yeah, there was some discussion about, well, should we actually keep that in, because the advertising document, proxy document is very old and expired, and can take very long to complete, maybe. So
Okay.
that was the question, I think. But still, yeah, in the current latest document, it's still in there. But
Okay, so it's
yeah.
there now? Okay,
Yeah.
thank you.
that's maybe more like a snack working group discussion.
Yeah, and that's what
But thanks for flagging that. Yeah. So I'll just assume it's still in here. Okay, so this was about that open issue. So we need to look at more carefully at the wording there. Let's see, next steps. So the plan is, of course, to resolve open issues, address TBD and to-do items in the text, which are also there, besides the issues. So we have a few things to do. And another one I wanted to add was, looking at the review that's happened with Snack Router documents recently, Snack Simple. There was a lot of discussion coming up about the shoot level requirements. So maybe it's good for the working group to look at that now already instead of pushing that to the future. So to avoid any questions about that, like why is it not a must, why is it not a may, and what are the consequences of not meeting that requirement? So we should maybe do a pass through the text. So there are 3 items that are in that category. There was a quick count I did. So if we want to keep them as should, then we should be complete, and then mention also what are, for example, allowed exception cases, or what are the consequences of not doing that requirement. Or we could even convert it to a must in the cases where we think that's better. So that's for the next step, and I think this might be the last slide. So there's no more things to present. I don't see any really big issues for the draft at this moment. Thank you.
Thank you. So let's move on to advertising proxy. Okay.
Okay, so this document has been languishing for a long time because we wanted to get TSR ready, and at this point TSR is almost ready, so time to go. Thank you. So basically, I just wanted to go over the remaining issues on the document. We did an update of the document about 2 years ago that changed the way the document works to make it more, rather than being like, oh, you got an SRP update and now we're going to do some MDNS, to make it be like, oh, you have a DNS zone, here's how you replicate it in MDNS. So the current document basically is structured that way. And the idea there is just that it shouldn't really be dependent on SRP. We want the advertising proxy functionality to be possible regardless of what the back-end data store is. So the remaining issues there, and these are just the issues from the issue tracker mostly, although the last one is from an email I sent to the list. The question is, there's a question about whether we should or should not advertise link local addresses. I'll talk about all of these in later slides. There's an issue of overemphasis of MDNS conflicts, like there's a lot of text about MDNS conflicts, which isn't very clear. There's discussion about SRP replication behavior that, which is really about multi-proxy behavior that I think needs to be clarified, and there's an issue on that. And then, oh, right, yeah. Then the issue of whether you might have a client that's an SRP client initially does a registration with SRP and then later switches to using native MDNS because it doesn't want to be sleepy or whatever. And how does that handle? And I think we need to specify that. There's the question of whether we publish key records in the MDNS or not. And then there's the question of what TTLs to publish. And then just sort of, my comment to the mailing list was about vague normative device or lacking normative device for TSR and name conflicts. The document is just sort of like, here's what could happen with name conflicts. Good luck. So I'll go into the detail now. So the issue with scoped addresses, and the issue on the tracker is basically about link local, but it's really a scoped address issue. And I sat down and thought about that a little bit last night. And sorry, this is really low. Oh, shoot. Multitasking with one hand. Yeah, so, here we go. Scoped addresses. Yeah. So what I realized is that there's actually like a couple of cases for scoped addresses, and there's also a couple of cases for implementations. And I think that we can specify this in the comment I have on GitHub. I wrote some text that I think actually specifies this pretty clearly. Could use some wordsmithing, but basically I think it's pretty clear. And basically the idea is, if you know that an address is routable on a particular link, then you should advertise it on that link. But you might not know. You might not be able to know, right? So that's a thing to bear in mind. So this doesn't apply if you are not able to know that it's routable. If you know that the address is on link for a particular link, then you advertise it on that link. But you might not know what link it's on link on, in which case you don't do that. And then, so if you don't know, then the only reason if you have a link local address and you don't know what link it's valid on, and you have other addresses, then you don't advertise the link local address, because there are other addresses and we know that those addresses should work because they're routable, at least in principle. So better to use them. And then for all other addresses, if we don't know whether the address is valid on the link or not, like if it's reachable on the link or not, then it's safe to assume that the stack does, because the stack, we hope, implements the not yet published source address selection document, or at least it implements the old source address selection document, source and destination address selection. So therefore, we can just hand that address to the stack and expect it to say, "Oh, I can't do anything with that if it's not a good address," and so we don't have to be responsible for that. So basically, the idea is, if you have a super smart implementation that knows everything about routing, then it can be very careful and specific about what it does. But if you don't know that stuff, you don't have to do. We have a clear set of requirements that we can specify for the sort of, dumb server that doesn't know about the routing table, use case. So, and also in addition to the routing table for link local addresses, in order to know that a link local address is on a particular link, you have to have some kind of communication, because that information obviously is not in the DNS zone. The DNS zone just lists the address. So, and you can't look at the address and say, oh, this address is on link because of the prefix, because it's link local. They're valid on every link. So that's why this calculus here. So if we have some way to record that the address is link local and what link it's local to, then we publish it. Otherwise, we only publish it if it's the only address we have. So MDNS conflicts. So this is the same discussion we were having with Karsten earlier. So the thing about MDNS conflicts is bearing in mind that the advertising proxy is intended to replicate a DNS zone. If you can have the DNS zone have a name that is not the same name that's being used for regular MDNS, then there's no possibility of conflict between DNS and MDNS. And SRP already deals with conflicts within the DNS zone. So therefore, we can assume that there aren't any conflicts in the DNS zone. And if we're able to advertise the correct name, if we're able to advertise the name as a subdomain of .local rather than as .local, then we don't have to worry about conflicts. Of course, that's not always going to be the case. Well, I should clarify. Right now, I am aware of a number of application implementations that I at least consider important that handle this incorrectly. The correct behavior should be that if you see a PTR record advertised on .local, you use the host name that you find, you see a PTR record pointing to a service. And so there's a service instance name on the right-hand side. You look up that service instance name, right? The problem is some implementations don't look up that service instance name. They look up the service instance name .local. So if it's service instance name .foo.local, that fails. That's less of an issue on Apple platforms because there's a standard API on Apple platforms for doing that particular piece, but it can be an issue. The next issue is once you do the SRV lookup to get the host name, it's not at all uncommon for the application to just fall over if the host name is not something .local. I don't know why that is, but it seems to be the case. We see that, for example, with Matter. And I think in the case of Matter, it's just that it's expecting the host name to be exactly a certain length that allocates exactly that buffer size. And if it's any longer than that, then it falls over. So there are some issues that need to be resolved in order to use subdomains of .local. But I think the question is, do we want to preserve old bad behavior or do we want to fix it? And personally, I feel like we should fix it. And if that's the case, then what we should do is try to come up with a solution to this problem that doesn't make our lives worse in perpetuity. That is to say, we still need to make it work, right? But let's make it work in a way that we can eventually turn off. And so I would like to have a little bit more of a conversation about this, and I don't see anybody jumping up to talk about this at the mic. So, this is probably something we can have a conversation about on the mailing list. But I'd like to do some more research on this and figure this out. The problem with that wish is that we would also like to publish the advertising proxy document because we have other documents that are depending on it. I think I have an idea for what to say here. So I'm going to propose that idea and bring it up for discussion on the list. And I would like I'm asking people to please participate in that discussion. Let's try to figure this out and get it resolved quickly. There's no reason that it needs to take a year to figure this out. That's my theory there. I had another slide about that. Yeah, so that's basically, this slide is just talking about what I just talked about. And so the approach that I'm suggesting we should do is a hybrid approach where, normally we won't see a conflict, right? With Matter devices, we generally don't see a conflict because the names are guaranteed unique when they're registered. With other devices, like printers, they usually use a random hexadecimal hash at the end of the name to avoid conflicts. So the likelihood of conflicts is relatively low. But if we get a conflict, then we can have a fallback, right? So the fallback would be, okay, we got a conflict, and what it means to get a conflict is also complicated, because like if we want it to be the case that we register the name in a subdomain of .local, like so we're the way that's going to work, just to for folks that understand sort of the way that MDNS queries work, the PTR record would be in local, because PTR records don't have to be unique. So you've got 15 services. All of those services are advertised under a service name with a PTR record. The PTR record points to the service instance name, which can be anywhere. Like it could be in foo.com. It doesn't even have to be a subdomain of .local at all, even though the PTR record is advertised in the local domain. So, so then the question is, what do we put on the right-hand side of the PTR record? What I'm suggesting is we put, we use a subdomain of .local for the advertising proxy. And so the host name, for example, would be Ted's laptop dot the name of the data set .local, not Ted's laptop .local. So in that case, we're never going to get a conflict, but we may have some devices that will fail if that's the name. So we may have to have a heuristic where for some period of time, we actually also advertise that name under .local just to deal with broken clients. So in other words, we have Ted's laptop dataset ID .local plus we have Ted's laptop .local. We advertise both of those records. And then it's possible, we're never going to get, hopefully never going to get a conflict on Ted's laptop dataset ID .local, but we might get a conflict on Ted's laptop .local. If we get a conflict on Ted's laptop .local, then we need to have a strategy for dealing with that. And that kind of ties into some of the stuff that Karsten was talking about in his presentation. And actually being able to report back to the SRP client that this happened, I think is useful. It's a little challenging because the advertising proxy draft disconnects SRP and MDNS, advertising proxy. So SRP is updating a DNS zone, and advertising proxy is replicating the DNS zone in MDNS. And those two things don't have to be in sync in the advertising proxy document. So that means that we may not actually know there's a conflict when the SRP update happens. But if we do know that there's an update when the SRP, if we do know that there's a conflict at that time, we could report it back to the client. So that's useful. But the other thing we can do is we can do an ad hoc renaming so that we get some kind of domain name on .local that works, even if the name the client picked didn't. Esko?
Yeah, that's good. Just a question in between. So you talked about Ted's laptop.local. So one idea could be that you kind of only switch to the longer name in case of a conflict.
Right.
Popping up. So that's one idea. And there was another one that might be too simplistic. It's just, yeah, that the advertising proxy basically stops advertising and reports the conflict back to the process that requested it. And in which case, if it's in SRP registrar, then at the moment, I don't think it can do anything about it because it's
right.
It doesn't have a way to tell the original client that information, right? So,
yeah,
but
it
could say it pushed the problem out away
from
advertising proxy to the process that's
the issue is like that means that you have to have a heuristic on the client. The client gets a report that there's some issue, and now the client has to do something, and that client is a light bulb. What is it going to do?
Yeah.
Nothing. Like it's just not actionable, right? So I think that it doesn't, like, you know, there are cases where maybe there's something that's claiming a name that it wants to have, and we'd like to tell it that it didn't get the name, and so we should definitely have a path that makes that possible if we can. But I think that is a nice to have, not a requirement. I think the important thing is that it has to work. Like you have to be able to discover the thing. So maybe that means that its host name isn't the host name that it chose, but at least the service name is correct or something.
Right.
That's the thing we have to figure out. So,
okay.
Yeah, so basically and by the way, the reason for always publishing the subdomain of .local is that's what I would like us to land on eventually. Like, think about this as like the old API and the new API.
Yeah.
And the old API is directly under .local because some things break if they're not. So we have to support them. But going forward, what we'd like is to have a protocol that never gets conflicts, right? That's our goal, I would hope. And if our goal is to have that, then we have to support that from the get-go. If we don't support that immediately, then clients that behave correctly in that situation can't behave correctly in that situation because we're not advertising the thing that they would look for. So I want to make sure that those clients, the ones that are doing things the new way, work from day one.
Okay. All right. Thanks.
Yeah. And by the way, I want that. The working group is welcome to debate with me about whether we should actually do that. We have Karsten.
Yeah, hello, Carsten here. I think there's just fundamentally somewhat different use cases, and I think we're sort of trying to cater to different use cases, but maybe they need different solutions in some sense. Like, for example, you mentioned Meta now. Meta sort of uses these unique by design service instance IDs, but it also expects that it can directly look up a service instance ID because they're constructed from these node IDs. So they expect them to be able to a client to directly look up the service instance ID and look it up without going through the pointer record. So in that sense, the solution of saying like, hey, let's just, when you just put them into a subdomain, you're sort of saying like, hey, yeah, great, we can't have conflicts because we're just going to put all these records alongside each other into different subdomains, and then you're saying, and now it's up to the client to find which one of these different records is the one that they actually wanted. So I don't know that doesn't directly work for Meta as Meta uses MDNS currently. Like, I think that's
orthogonal though, right? So what you're talking about is that we have to advertise the thing that Matter's expecting to find until Matter gets fixed, which I think it should be. I think that's broken behavior.
I think that's a separate discussion, maybe whether Matter should be fixed. But I think you're fundamentally taking a service and you're just sort of saying like, hey, service names are just no longer unique because we're just going to throw them into these subdomains. So you're fundamentally changing the model.
Matter changed the model. This is not us changing the model. Stuart?
Yeah, let me give some background here. So we have to be careful to remember there's two levels of names we're talking about. We're talking about service instance names and we're talking about host names. Sometimes we care about the host name. If you're going to log on to your device on the command line using SSH, you want a short, convenient, memorable host name so you can log into mycomputer.local or whatever it's called. There are many cases where no human being ever sees the host name and it doesn't matter. The user interacts via the service level service instance name. So when I want to print something from my phone with AirPrint, I see the rich text name of the service with capital letters and spaces and everything. What host name it has, I don't see and I don't care. And that can be some random hexadecimal string or whatever. And it only exists as glue to link the SRV record to one or more address records, maybe on multiple interfaces.
Yep.
Now in Matter, I wouldn't say they broke the model. That's why I want to explain. Every device in Matter has an ID which is unique, and when you want to turn a light on, your device has a database that maps those user visible names to the actual identifier, which is a cryptographic key, and the part of the security is based on unique private keys and public keys. That's the service name. So when your phone says turn the bedroom light on and it says, oh, this Matter device ID is this 32 character hex string, it's looking up that as the service name, not the host name.
Right.
What host name it maps to doesn't matter. If there's a conflict there and it renames, Matter shouldn't care. There may be bugs, but at least in principle in the design, the service names are prescribed by Matter, which they can do because they have their own service type. It's _matter.udp.
Right.
And within that namespace, they are free to define the rules for their namespace, and they have.
Yep.
When it comes to host names, they don't own the namespace. But fortunately, it shouldn't matter, because if there are conflicts and they get renamed, the SRV record will point to the right host name, which you then look up. So I don't see any serious fundamental problem here. We may need to write some text explaining it. We may need to clarify some confusion, but I don't think we have a catastrophic problem to be fixed.
Right. No, the issue is that right now Matter doesn't do local browsing or legacy browsing domain discovery. And so it just says, oh, the legacy browsing domain is .local. I'll just look there. It'll all be great. And that is a correct assumption. Sometimes.
I mean, I think to be strict, Matter's not doing browsing at all.
Right.
It knows the device ID that it wants to talk to, and it looks up that SRV record
in a specific domain.
It is that device ID .matter.udp.local.
TCP. Yes.
Is it?
It is. Don't get me started.
Well, there's different use cases, right? There's commissionable device discovery, which works differently, which uses more what you would call proper browsing, and for operational discovery uses these node ID based. That's when you actually turn the light on.
Commissionable discovery is the more traditional kind of discovery that we'd think of in this group, which is there may or may not be new products I've unboxed waiting to be commissioned. So let's ask the network, give me a list of things awaiting commissioning. Oh, there's 3 of them. Okay, let me read the manual and find out how to do that. So that is definitely a browse, discover, connect flow. Once you have set things up, it is more, and this is not unique to Matter. On my Mac, if I go into system settings and go to the printer section, when I click plus to add a new printer, it will browse the network saying, are there any new printers I don't know about? It'll show me a list, and I can add one and configure a print queue for it. Having done that, every time I hit Command P to print, it doesn't browse the network saying, show me all the printers I don't care about. It's remembered the name of the printer, and that's the printer it looks up.
So it remembers foo._ips._tcp.local specifically?
I know you're asking about the .local. I believe, I'm pretty sure, it remembers the string that it got back from doing the browse when you created the print queue. And it is worth pointing out that phones and computers, for historical reasons, are different here. On your Mac, you typically make a print queue as a one-time operation, and then you reuse that many, many times to print on that printer. With AirPrint on the phone, you don't make print queues. Every time you want to print a photograph, you've got to go through that browsing experience, and you may pick the same printer every single time, but it still makes you see the list and pick one every single time. And that was just a design decision that the respective HI teams made. But yes, on the Mac, the browse and make a print queue is a one-time operation, and then subsequent uses of that do not browse again. They just look up the name that they remembered.
Yeah, I guess what I'm getting at is that there's a semantic issue here that we haven't really, we just kind of backed into without really thinking about it, which is that, and we run into this with Matter because, of course, Matter works on thread. And you need to be able to discover Matter devices through thread. And those Matter devices, when you're discovering them on thread, are not advertised in the .local domain, right? They're advertised in the default.service.arpa domain. And so we actually have a specific hack in the Matter code right now that says, look this thing up using .local and default.service.arpa, which I consider kind of ugly. And I think that it might be valid to say, give me a list of default legacy browsing domains and try to look this thing up in each of those legacy browsing domains. I think that would be not great. I'm not fond of that semantic, but it's sort of okay. What I would ideally like is that we first look for the PTR record and then use the name we see in the PTR record, because that gives us a clear indication of where the thing is. It's not really a browse per se, because we're looking for a specific thing, but it allows us to get the correct current location of the thing rather than just assuming that it never changes, which is what the code currently does. So I think, I mean, this is actually like, I'm glad we're having this discussion because I think it's an important discussion to have. Like, how much do we care about the flexibility that Browse gives us? Yeah, because like, think about, printers here.
I see the timer. I think that means we're out of time. Oops. We're probably not going to answer all of this right now. It is a good discussion to have. Yeah. One of the considerations is, and if we do the unicast local discovery, it maybe makes this more of a moot point. But with multicast discovery, if you have 100 light switches and you want to turn one of them on, sending out a multicast to get 100 light switches to all answer, and then you ignore 99 of those responses and only use the one whose name you already knew before you did the query.
Right.
That is very wasteful in terms of multicast traffic. If you know the name of the thing you're talking to, just talk to that thing. Don't pre-flight that with a hello, everybody. Now I'm going to ignore you and carry on talking to the thing I knew in the first place. So that's the reason printing in particular has that flow, and we can debate if that still is the right thing to do.
Yeah. I mean, and we could also try it first, and then if it fails, go back. So there's a lot of things we could do about this. The point is, I'd like to solve the problem.
We have 5 minutes more slack in the agenda. So if you want to continue this discussion or run through the slides.
Let me see if there's something we really need to talk about. I think we've already kind of talked about this in the TSR document, but basically, and we also talked about it in the charter discussion that we might want to do some tweaks to MDNS to optimize the behavior that it has when there's multiple proxies advertising the same stuff. And then we need to deal with the case where we might have a device that uses SRP and later advertises native MDNS. We don't want there to be a spurious conflict there. So if we're using TSR, SRP is going to result in TSR getting used, then the native device has to use TSR. And we kind of don't talk about that use case in the document currently. So I just want to make sure the document A doesn't forbid that and B sort of talks about it. Karsten?
Yeah, just quickly wanted to say this is actually a use case in ULD where you, if you try to find the server, there isn't one, so you do MDNS yourself, and then later you switch to using the server, or you might switch back if the server goes away. So that's kind of I was thinking we might want to mandate TSR for ULD clients when they're falling back to MDNS.
Yeah, I agree. This is actually why this sort of came up. Okay, key record publication. We don't really need to resolve this here, but just FYI, there's a question of whether we actually want to publish key records in MDNS. We need them for SRP in order to disambiguate, like to avoid conflicts that are real conflicts, but they're not actually necessarily useful in MDNS, except that we do use them to hold the name that's registered. So if we don't use the key record, we have to use something else. And there are potentially privacy issues with the key record. So that's the reason not to do it, not to publish the key record. And then there's the question of TTLs. And it's just like, what TTL do we choose when we advertise MDNS? Because we're replicating what's in a DNS zone. Obviously, we don't want to use a TTL longer than what's in the DNS zone. But what if the TTL in the DNS zone is 1 second? We really don't want to advertise a 1 second TTL in MDNS. So we just need to specify that. And right now, I don't know. I think we do talk about it, but I think we need to get more clear. I think that was an issue that ESCO raised. And then the vague normative device, I think we need to actually explicitly say how name conflicts are dealt with. And I think we need to introduce TSR a bit more clearly than we currently do. So right now, the discussion of name conflicts basically says, here's the problem, and to solve it, you could do this, or you could do this, or you could do this. And what I'm saying is I think we really just need to say, here's the problem, here's how you solve it. So that's all I had. And we would like to actually work on this document now that TSR is pretty much done. And so, yeah. That's where we are.
Okay. All right. Thank you, Ted. So now we'll move on to 6.0. There we go.
Donald. Oh. Do you want to? So we have the slides on screen, but would you prefer to share from yours?
No, I'd be happy to
Okay.
run the slides there. So I'm Donald Eastlake. I was the author of the original SIG0 RFC 2931. And I'm going to talk about that and its deficiencies, and this draft proposes an improved SIG0RR. So typographically in this presentation, I use SIG space ZERO to refer to both of them. And sometimes to distinguish them, I may have to pronounce the parentheses sometimes. But so SIG0, a lot of people know, I'll try to go through these slides fairly quickly. It's a meta resource record, which is used for providing security on requests and transactions to the DNS based on public-private key signatures. Because it's a meta RR, you can include it in messages, but it's not stored in zones. And the corresponding public key used to verify these signatures uses a key RR, which can be stored in zones, or it can also be included in messages, as is done with SRP, as I understand it. So it's just what it looks like. So you can send a request, you include the request signature in with the request. Of course, it doesn't actually cover the signature itself, but it does cover some metadata for the signature. And for a transaction, in the response, you include a signature which covers not just the response, but also the request. So you can tell if you verify the signature that the request was not tampered with, and that the response is a response to that request, and the response wasn't tampered with on the way back to the requester. So this is a little bit of a noisy slide, but here's sort of what's going on. This SIG0, it is used with DNS update messages, is used with T keys to negotiate secret keys in other cases. And the service registration protocol uses SIG open paren 0 close paren and update. And there's also a new draft, well, relatively recent draft on managing DNS delegation, which is in DNSOP on the bottom right here, which also uses SIG0. So just a little more about usage here. So the general DNS update, you basically sign it with something which indicates your authority to make that change. This is like you're changing some entries or adding or deleting in a regular DNS zone somewhere. For the service registration protocol, FCFS, you basically claim a name by including the key in a signed request. And for DNS, the T-key one, you'd usually use that to give some sort of signature indicating authority for the host that's using T-key to negotiate a secret key. So these are different uses. Brief diversion, there is also T-sig, which, as you can tell, because it has a RFC in the 8000s, it's been updated much more recently than these other things, which like SIG open paren 0 close paren, which currently have RFCs in the 2000s. It's the same sort of meta RR, but it uses a shared secret key and a keyed hash rhythm. It's more efficient and compact, but the problem is you have to have configured a bootstrap to this shared secret key. It's not used by service recovery. Yes, it also has, because it uses a shared secret key, the server can impersonate the client, but that's usually not too much of a problem. I just thought I would mention that exists. So what's the problem with SIG open paren 0 close paren? It has no original ID field in it. So if you forward it, that's not obviously supported, and that's not a problem for a service recovery protocol because you don't use regular recursive DNS forwarders, as I understand it. But it is a problem in other cases. These are the general DNS zone update messages. Forwarding should be avoided where you can do that, because every forwarding level is a place where you can have problems or with reliability or otherwise. But sometimes if a client just wants to update something in a regular DNS zone with a DNS update message and doesn't know where everything is, it just needs to use the regular forwarding mechanism. Bind does manage to support forwarding by using a sort of a kludge using DNS and duplicating the ID space for that TCP connection. So current problem is that you cannot have more than one sig open paren 0 close paren in a particular message. So this forwarding, here's a case where sort of shows something being forwarded. I don't know I need to say much about this. This is say not applicable to SRP. This shows a general DNS recursive server. And here's one where it added also having two signatures. In this case, the hypothesis was that the requester wanted integrity to the forwarder and back. There was also a separate signature giving authority to the message, which the server needed. So these are just examples. So there are actually more problems in SIG open paren 0 close paren. It doesn't have any extensibility. It doesn't have any extended error field, and it has no way to indicate anything about the state of the keys. It's a separate draft currently in DNSOP on key state, which says you might want to indicate the state of the key. And here's some example states at the bottom. So that would be a useful thing to add, in my opinion. So how do you solve these problems? Well, there's three basic ways. You can use a new resource record. You could overload fields in the existing SIG open paren 0 close paren, like putting an error code and an original ID into the TTL field, because TTL isn't used, or you could use EDNS options. And what are the characteristics of these solutions? Well, new RR is a complete clean solution, but the problem is, of course, you have to use the new RR to get those benefits. Overloading the fields, it might be backward compatibility problems, not as bad, but it also will limit the extensibility because there's only so many fields that you can overload. And if you extend it with EDNS options, that's not too bad, but there's a problem that you have to link between the options and the particular SIG open paren 0 close paren. If you were ever allowed multiple SIG zeros of that type, then it gets difficult to reliably link the particular EDNS option to the particular SIG open paren 0 close parens that they apply to. So this draft, what things does it have in it that are changes from the original SIG 0? It specifies, sort of fleshes out this new SIG 0 RR, and in the draft that would be recommended, and use of the old open paren 0 close paren version would not be recommended. It adds sections on how to do forwarding and advocates that you avoid it where you can. It makes a bunch of other minor changes, like removing the statement in the original 2931 that TCP support for SIG open paren 0 close paren is optional. So here's the current state of the new SIG 0 R data. As you can see, it has a time signed and a fudge amount of time. So it's basically, it indicates that the signature is sort of valid for a small window with a fudge amount around that. The SIG open paren 0 close paren is originally from DNSSEC, so it has a beginning and ending time because it's assumed to be a long-lasting signature. But the new SIG 0 recognizes that it's just for a particular request. So what should be done? I'd be interested in any comments and things, or any questions people have, and I'd like to resolve those. And if they can be resolved, and there seems to be some sentiment in favor, we could perhaps go for working group adoption. This draft was moved from DNSOP to DNS, my personal draft, from DNSOP to DNSSD because of its applicability to the service registration protocol. However, since now there's also this delegation management thing in DNSOP, I'm not sure that choice is necessarily still the right thing.
Hi, this is Unray ISC with my implementer's hat. This doesn't make me really happy because we will have to support both, but I would like to contribute to the security section because it's important to remember that 6.0, both of them, is ACL. And so you need to resolve the 6.0 validity, and that's cryptography, before you apply the ACLs. So if the 6.0 is the only ACL, it means there's a attack vector on any DNS software that accepts the packets with 6.0, and there needs to be some plumbing around that to just not overwhelm any DNS server, that any application that accepts the 6.0 as ACL. So I don't care where this ends. I think this is fine, but I would like to, make sure that we don't end up with CV again.
Okay, I'd welcome additions for the security section, or suggested additions for any other section.
Okay, thank you. If you have any other thoughts, please take them to the list. Now we will move on to Francois.
Hi, everyone. Can I get the clicker?
Yeah, working on it.
Thanks. There you go. All right. So earlier in this meeting, we discussed how we could use unicast service discovery on Wi-Fi to be more efficient in terms of the spectrum. And as Stuart said during that part, we've already been doing that on Overthread for some time, exactly for those reasons. And so let's here take even one step further in the context of thread to explore a case where even SRP did not scale super well in some specific scenarios and what we can do about it. So I'm going to present some ideas and some results that we've been computing by running experiments. So in the scenario of thread, we can have a lot of accessories on the same mesh, and we can have sometimes some synchronization events when all the accessories will send the registration all at the same time. And in the context of Matter, the registration could be several hundreds of bytes, and that can basically cause congestion on the mesh. So these events could be, let's say, the SRP registry that gets a new version of the registry, or it could just reboot, and all the devices would have to re-register the services. So what we notice is that generally the accessories register the exact same service. So the registrar already knew that service. It was just disabled, but it was in its cache, basically. And so we asked that question, could we just avoid sending the whole registration of 600 bytes if the server already knows most of it, or all of it, actually? And so that's what we've been trying to do with SRP hints. All right. So let's take a simple example. First registration of an accessory. A thread device, it will send an SRP registration of 600 bytes. Everything goes well. It gets installed on the register. And it stores, the SRP server will store the whole query in its persistent storage. Then something happens, maybe the server reboots or the thread device reboots. And then instead of sending again the whole query, it will send what we call a hint, which is simply a small 4 bytes hash of the whole query, a transaction ID and a key ID. And then the server can just look in its cache for the hash. If it's present, it will republish the registration. And now we've been sending 8 bytes instead of 600. And so we've been running experiments about that to see if it actually helps our convergence events. So we have a testbed with 51 devices. One of these is the boiler router, which is the SRP server. And then the 50 other devices are Matter devices of a thread that will register their 600 byte service. So in that experiment, we measured the SRP convergence time. It's the time between the first and the last successful registration among the 50 accessories. And here are the results. First, with hints disabled. I'm just showing with hints disabled. You could see that the convergence time could be even 2 minutes just for 50 accessories to all register their service. And when we enabled the hints, we got a way better result. On average, we reduced the average convergence time of more than 30 seconds. And the variance is way lower as well. So the extreme cases are performing way better. So that's encouraging results. So we'd like to continue our work on that. But here's where I would like to have a discussion and have feedback from you too. Right now, the hints are running on port 53. The only way we are able to distinguish between a SRP hint and a DNS packet is the packet size. An SRP hint is 8 bytes. A DNS packet has a 12-byte header. So if the packet is smaller, we assume it's an SRP hint. So of course, maybe in the future, we'll use larger hashes and stuff. And so it could be bigger than 12 bytes, and then problems could occur. So basically, what should we do? We could also prevent ourselves from having larger packets larger than 8 bytes. I don't know if it's doable, if it's really future-proof. So there are other solutions that we could look at. We could use different ports. We could make hints as part of a DNS packet. It would increase the hint size, so we would have to measure the impact, but it would be DNS compatible. Yeah, so that's it for me. So if you have any feedback or question about that work and that results, just let me know. Mm-hmm.
Eskodijk, a question about the reboot scenario. So in your implementation, the services are actually kept during the reboot, and then it still knows the information. Was it kind of stored in on a hard drive or in flash, or?
Yeah, it's all on a. We have a persistent storage that survives across reboots, basically.
Okay, so it's basically written.
Yeah,
out.
it's written on
it's
the.
only for a planned reboot, or is it? Does it always work?
No, it's always written on the disk, basically.
Okay.
Registration. We cache them in persistent storage.
So I think for many devices, it will just forget all the records in a reboot case. But if you are talking about like a version number increase that is used to trigger or request re-registrations, for example, then the device could still have everything in RAM.
Yeah, exactly. So if you don't write anything in the persistent storage, then the reboot case won't be solved by that. We actually write it in persistent storage, but as you said, if it's a version update, then it will still work with RAM only.
Okay. And then back to your last slide, I think, was with the solutions. So yeah, having on the same port number, at least intuitively, sounds like a good idea if you could construct a minimal DNS message that only contains, for example, something like a special option, and the option says like, okay, this is an SRP hint and includes the hash as well. Then your packet does get longer, but you can kind of more easily blend it in, hopefully, with the DNS SRP ecosystem. Yeah, so that sounds like a possibility.
Okay, thanks.
Erik Vink, individual contributor on this one. Honestly, using the same port for different protocols. Yeah, whatever. I don't think it will fly very far away in the IETF. Getting another port will be tricky though as well, right? So just beware of this. Just the questions now. If can you go back on the first slide when you were the one you're talking with? The one we are talking with is this one.
This one, yeah.
So the registrar, how long does it keep the record? I mean, it needs to be some garbage connection, right, at some point of time. Should it be part of the draft or not? I don't know.
So I think it could pretty much decide when it wants to flush it, because if it's not in the cache anymore, we can just re-register. I think the cache needs to be long enough for the hints to be useful. So I guess I would say several days, because the services in in the thread mesh at least don't change that much. Yeah, but if that has any opinion, don't hesitate to.
I think it may need to be set somewhere.
All right.
Even if it's left to the operator, right? Whatever.
Sure. Yeah. Thanks. Makes sense.
Yeah, I mean, you have to be careful that you don't just like consume storage without bound.
Right.
And that's, to me, that's the main motivation. Like it doesn't, the time isn't so much the issue as the storage. And also it is necessary to be strategic about what you store because, for example, some consumers of MDNS or of DNSSD vary their text record repeatedly to signal things, which I think is actually should be forbidden. I think that's a really bad idea, but it is something that is done. There are cases where it makes sense, but rarely. And so in that case, if you just keep caching those changes over time, I mean, if it varies between two stable states, it's no problem. But if it's like some hash changes or something, then you're just going to have a bazillion packets from that client. So you kind of need to notice that and discard them. And one of the reasons for persisting things is for a longer time rather than just keeping them in RAM is that you may have like 4 or 5 different scenarios in which a registration happens. And if you can remember all 5 of those, then whichever hint you get, you use it instead of like, oh, we just remember the last one. So there are good reasons to keep more data, but I just, yeah. And I think, you know, we could also use a new a new DNS code, or we could just do a new port and have it be advertised. Because like in Thread, for example, it's advertised in the network data, so it's really not.
Right. It makes it just slightly more complex, but not that.
I think that's probably the way to go because I think Eric is completely correct.
Yeah,
we're not going to get that through the IETF.
Yeah, definitely, totally agree. All right.
Stuart Shasha, I'll make my point quickly because I think I'm echoing what Eric and Ted said, and then you acknowledged in your slides that having this 8-byte thing that's too small to be a legal DNS packet, I think we all agree that it just feels wrong. Multiplexing on the same port, if we can have it start with some byte, I'd have to look at the DNS header format, but we may be able to do something that is unambiguously differentiated, that this is not a valid DNS message, and then you can have a reliable way of differentiating that. But I think just going off the length, and for the reasons that you said, we might want longer hashes later. So I think you correctly identified that's a bit of an ugly hack, and we should do better.
It's good for experiments. That's it, right? It was for the results. So easy. Yeah. All right. Thank you, everyone, for the feedback.
Yeah, I had one quick question. Do you see this sort of being useful outside the context of Thread, or is it really primarily an optimization for a Thread due to the extremely low bandwidth? I mean, it seems like on like Wi-Fi, even then a 600-byte packet isn't really that different from an 8-byte packet, probably.
So the goal here was especially targeted at Thread. However, at the beginning, we decided to do SRP and unicast discovery for Thread because Thread is resource constrained, but now we're starting to think of it for Wi-Fi. So maybe one day, if we have 10,000 of devices in the same network, we would use that on Wi-Fi. For now, it's just really for Thread, for the Thread case, and Thread's bitrate, which is very, very low.
Thanks.
Thank you.
Okay, thank you for that. So the final item is just a presentation that's related to the Dawn BOF, which occurs tomorrow. So it's just for information for this working group to raise your awareness. It's not one that should be discussed within DNSSD, but if you want to discuss it, then yeah, there is a Dawn list. Okay, go ahead, Frank.
Yeah, I think I'm basically here to ask for a little bit of help. So we do have a set of customers that, pretty much along the lines of what Stuart was saying, is discovering a printer similar to discovering an agent. Some people believe that, and they made us create a bit of running code to go and do that, so that you can go and find a pick agent in a warehouse, or that you can find a nursing agent that might be flown by a patient's room real quick. So there is use cases for that smell very much like what you have in DNSSD with MDNS. So local, constrained environments, air-gapped, non-public, and yeah. So what we've done is we clearly say, well, we only want to go and figure out how to go and get an entity, the URL, to then figure out more about that particular agent. So just the initial, like, how do you get to the URL with some maybe additional hints? Because not every agent necessarily has an agent card like with ADA, but there might be like agents that speak MCP where you don't really have an agent card. So URL to more descriptive information and maybe a hint to the protocol that you want to go and use to go and do that. And everything else is kind of, well, kept out of scope, because in certain environments you don't want to go and do anything else like Aussie and then and whatever. In other scenarios might want to go and do that. And what we did is relatively quickly say, well, we have a service record, and then we jam some information into a TXT record to go and help further. What we're not entirely sure about is should we use an agent TCP as a kind of a catch-all? Should we be more differentiated? Is this kind of two-stage split of just kind of finding the URL of where to find the agent, and then with some additional hints, maybe is that the right split? Should we really do TXT records because that was inspired by customers and saying, well, we don't really use service bindings throughout? If you look at the DNS8 work, they're really saying, well, let's go and standardize on service bindings records and then maybe have some other alternatives. We struggle with long strings. Is there a generic way to go and solve that? And yeah, well, do we need to go and put anything privacy into that document or not, right? So there's a couple of questions, and if you can help us on the list with those questions, we would greatly appreciate those. So that's to Eric's point, which was asking earlier on. So if you can help us, I very much appreciate that. Thank you. Sorry, I don't want to see you.
Well, I will say we're happy to help. I think we're also out of time for this session, but yeah. We can continue this with some hallway conversations and discussion on the mailing list.
Yep, feel free to. So that brings us to the end of the session. So thank you for all your contributions. And yes, we will follow up on the DNSSD list. Enjoy the rest of the week.
Are you also happy with having lunch today? Are you also happy with having lunch today? I think everybody says Monday is fine.
Let me check.